Delaware Tech, Chem 100, Chem 110, Unit 1 continued, problem solving, strategy, and use of conversion factors. So whenever we have a problem, the first thing you need to do is identify the unknown, both what type of quantity, is it length, is it time, is it mass, is it density, volume, etc., and the unit that you need to have that answer in. So if it's mass, does the questioner want the answer in grams or in kilograms, for instance? Or if it's a distance, should it be in meters or millimeters or kilometers? So you need to know both. The second thing to do is start writing down the known quantities that are in the question. Make a table if there are a lot of them. If you have a pressure and a volume, for instance, of a gas, and a temperature of the gas, make a table of each of those values. Say the pressure equals this many Pascal, or the volume equals this many liters. And that way you have it all there to look for when you're creating the problem answer. Plan a solution. How do you plan a solution? Well, if you know it's going to take multiple steps, plan a solution where you start with quantities you know. For instance, you have the mass of something. Ask yourself, what can I turn the mass into? And then ask yourself, what is being asked at the end? Maybe it's density. Maybe it's the number of particles that we're talking about. And you can ask yourself, okay, I know what I need to end with. What do I need to get to that end? And then you can work backwards from the answer as well as forward from the unknown, from the knowns. And therefore, you'll end up with a pathway that links the things you know to things you need to calculate first, to the things you finally will calculate in the answer, the unknown that you desire. So each step in that pathway that you created will either be a conversion factor, and we'll talk about what those are, or a whole separate formula. So you need to find or create your own conversion factors or formula in many cases. Now you have a table of formulas that you're given in the handout set, and you're given a table of conversion factors. Quite a large table of conversion factors is one of your handouts as well. You can always refer to that list. So in addition to that list, the periodic table is filled with numbers that can, under the right circumstances, be used as conversion factors. There are other conversion factors also on your handout. You can find them online if they're not there, but most of the ones you need, maybe even all the ones you need, are already in your handouts, or they'll be given to you in the problem itself. And sometimes plain old common sense will tell you what the formula is or what the factor is. For instance, you know that there are 60 seconds in a minute, therefore your conversion factor is 60 seconds per 1 minute, or 1 minute per 60 seconds. You need to find your correct formula. You're given a table of formulas, and some you may have to generate yourself. So write down the formula, then solve for the unknown variable without even putting the numbers in. A lot of people like to put the numbers in right away without solving for the unknown that they want. For example, what if you had a problem where you know the formula says A equals B divided by C, and you were asked to determine what C is or what B is, not what A is. And maybe you were given the other two values. So let's say you were asked what B was, and you were given C and you were given A. Well, this is the thing you need to solve for first. So rearrange your equation. You can move the C that was on the bottom on the right to being on the top on the left. Now remember, if a number is by itself, it's already on the top. So you can convert this formula to A times C, and you could write a little dot in there to show times, or you don't have to if it's just variables. And that will equal B. So now you know the correct formula, the final formula, and now you merely input the values you were given for A and the values you were given for B, and calculate, values for C, and then you will calculate B directly with your calculator. So then you put in the numbers after you've created the correct formula, the finalized version of your formula. Once you've calculated, check, recheck, and maybe even recheck again, because people have problems typing in numbers on small buttons of calculators. That happens all the time. I have that problem happen all the time. So you always want to recalculate on your calculator and make sure you got the same answer twice. If you didn't, do it a third time. Once you are convinced you have the right number, and maybe you're still not sure, first make sure that you take the number that the calculator gave you and round it to the appropriate number of sig figs. And we've already talked about the rules for doing that with multiplying, dividing, and the rules for doing that with addition or subtraction. Make sure you have the right unit. If the question asked for kilograms, don't give grams. If the answer was asked for joules, for instance, a unit of energy, don't give kilocalories. Does the answer make sense? And a lot of times you can look at the answer and say, does this make any sense to me? I got an incredibly small number. Should I have gotten an incredibly small number? Or I got a number that's only a little bit larger than my original number. Does that make sense? There are lots of questions you can ask to check. And if it doesn't, make sure your formula is right. Make sure you input the correct numbers. Always go back and make sure your numbers in your table were copied correctly from the original problem. A lot of people miscopy numbers. It's very easy when there are a lot of digits. So once you have your strategy, we can use things like conversion factors. Well, let's talk about what conversion factors are. Conversion factors are disguised versions of the number 1. Okay, what does that mean? Well, we know that 1 foot equals 12 inches. We know the thing on the left here is exactly the same as the thing on the right, or equivalent in some way. 1 foot is the exact same length as 12 inches. Now, I could divide both sides of this equation by 1 foot. So the left side of the equation would be 1 foot divided by 1 foot, or the number 1, and the right side of the equation would be 12 inches divided by 1 foot. But we know that this is equal to 1. And if I had taken this original equation and divided both sides by 12 inches, the left side would become 1 foot divided by 12 inches, and the right side would be 12 inches divided by 12 inches, or 1. Therefore, conversion factors are equal to the number 1. And in fact, you can convince yourself of that. You know that if you have a fraction where the top, the numerator, is equal to the bottom, the denominator, well, that number, the whole fraction, must be equal to 1. And it's always okay to multiply any number by 1. You won't change its inherent value. So if I multiply either one of these conversion factors by some other number, it will change the appearance of the number, but it'll still be the same because all I've done was multiplied my original number by some version of 1. Here's another example. In metric system, it's very easy because everything's based on powers of 10. 1,000 meters is equal to 1 kilometer. In fact, the kilo means 1,000. You could take the words 1 kilometer and actually translate that to 1,000 meters directly. The prefix tells you exactly how many it is. So in these kinds of conversions, in both the top and bottom example of the conversion factors, these conversion factors have infinite significant digits. Why? Because in these particular cases, 12 inches is exactly 1 foot. 1,000 meters is exactly 1 kilometer, and therefore, when we divide one by the other, the numbers are still exact. Remember, if you start with a large number and have a small unit, you're going to end up with a small number and a large unit. And likewise, the other way around. If we start with a small number and a large unit, we'll end up with a big number and a small unit. For example, look at the conversion factor right there above. 1,000 millimeters, actually this is millimeters, not meters, 1,000 millimeters equals 1 meter. Well, millimeter is a much smaller unit than meter. In fact, it's 1,000 times smaller than meter. So our number must be 1,000 times bigger with that small unit. And it is. 1,000 is 1,000 times bigger than 1, and a millimeter is 1,000 times smaller than a meter. So they match. You will always know that you've done it wrong if you suddenly get a bigger unit and a bigger number, or a smaller unit and a smaller number. That tells you that you probably divided when you should have multiplied, or vice versa. So, as I mentioned, conversion factors are disguised versions of 1, so they're equality statements. If 1,000 milliliters equals 1 liter, then we know 1,000 milliliters over 1 liter is equal to 1. but we also know that 1 liter over 1,000 milliliters is also equal to 1. So we could use either one of these in some equation because these are just disguised versions of 1. An inch is exactly equal to 2.54 centimeters, so we can create two conversion factors for that. We know the density of gold is 9.3 grams per milliliter. In other words, it has a mass, 1 milliliter has a mass of 19.3 grams when we're talking about gold. That's actually quite high. This is the density of gold, and we know that gold is very, very dense. It has a lot of mass for a small amount of volume. By comparison, by the way, water has a density of 1 gram per mil, so gold for the same volume is 19.3 times more dense, or if you weighed it, it would be 19.3 times heavier for the same volume of gold versus water. But anytime you have a unit where there is one unit divided by another unit, this should be an immediate clue to you that this number alone can be a conversion factor and rewritten as the original number with the top unit divided by 1 of the bottom unit. And you'll notice in each of these cases, I have 19.3 grams over 1 mil, and I can invert that and write 1 mil over 19.3 grams. Be sure not to move the 19.3 with the mils. It is associated with the grams part of that, and it's per 1 mil. The speed of light has a very specific number, and this is an exact defined value. It was defined in 1982, so it's exactly this speed, and the speed is 299, 799, 458 meters for every second. In other words, that many meters per 1 second. Light is extremely fast, and so that's an enormous number of meters that it travels in a single second. So we can write that number of meters per 1 second, or we could write it as 1 second per that many meters. That is a conversion factor. And by the way, in every one of these cases, if you look at the unit in the top and the unit in the bottom, or vice versa, these conversion factors allow you to convert one of the two units into the other of the two units. So if somebody gives you this 19.3 grams per mil, you know that you can use that to convert grams to mils, and you know that you can use it to convert mils to grams. Likewise, if you have the speed of light, and you know that something is traveling at the speed of light, and somebody tells you it went this many meters, you can convert that to time in seconds. Or if somebody said it traveled for this many seconds, you can convert it to that many meters. So every time you have a conversion factor with a unit divided by a unit, that allows you to convert one of the two units into the other of the two units. So we've already talked about similar examples. 12 inches equals a foot, 100 centimeters. Remember, centi is 100th of a meter, so 100 centimeters equals 1 meter. And all metric to metric conversions based on powers of 10 are all exact. They're all defined. 100 centimeters equals a meter. 1,000 millimeters equals a meter. 1,000 meters equals a kilometer. Those are all exactly the numbers that I just gave you, and therefore they have infinite significant figures. Now, why is infinite significant figures important? Well, remember we learned in one of the other units here, the video units, that when you are calculating sig figs of your answer, if you're multiplying and dividing only, your answer will have the number of sig figs that was the lowest number of sig figs of all your original numbers. Well, if you're starting with conversion factors that either have high numbers of sig figs or infinite numbers of sig figs, you know that your answer will have the same sig figs as your number that you started with. In other words, if I have 1,000 mils per 1 liter, this first conversion factor, and I'm told a certain number of liters, maybe I'm told 4.579, that's 4 sig figs, that many liters, 4.579 liters, I have 4 sig figs to start. Well, I'm multiplying it by conversion factor that has infinite sig figs, so my answer will also be 4 sig figs. So if you have conversion factors that are always infinite sig figs, your answer will just have the same number of sig figs as your starting original number. Now, if it doesn't have infinite sig figs, like this 19.3. That is an estimate. 19.3 is the best estimate. It only has 3 sig figs. Well, if your number has less than 3 sig figs to start with, well, then that's no problem. But if it has more than 3 sig figs, you have to round to only 3 sig figs, because 19.3 is only 3 sig figs, even though the 1 mil is considered infinite in this case, because it's about 19.3 grams for exactly 1 mil. That's the way you think about these. So equivalent statements always will have the relationship, as I mentioned before. A large number with a small unit will be associated with a small number with a large unit. And here are other examples. Let's look at the second example. 1.609344 kilometers equals 1 mile. Well, just by looking at these numbers, we see the first number is larger. Well, then we know the kilometer must be this smaller unit. Kilometer, in fact, is smaller than a mile. It's about 6/10 of a mile. So we have a larger number with the smaller unit, kilometer, equals the smaller number with the larger unit, mile. If we look at the last example, 1 million microliters equals 1 liter. A microliter is a very small volume. It is 1 millionth of a liter, and if we have a million millionths, well, that is 1 liter. So let's look at some examples of creating conversion factors. Now, conversion factors can be either these exact equivalences of quantity, length to length, time to time, volume to volume, mass to mass, or they can be equivalencies based on rates. For example, if I said 60 miles per hour, that we know 60 miles is the amount you've driven in 1 hour. Now, we know that 60 miles is not the same concept as 1 hour. One is distance and one is time. But there's an equivalency there based on that rate of 60 miles per 1 hour. So therefore, we can use rates as conversion factors, as well as our standard conversion factors of exact quantity to quantity conversions. So the first example here, there are 5,280 feet in a mile. This is an exact conversion, by the way. And you won't always know this unless you're told that this is exact. So I will let you know when things are exact, or you'll see that there are so many significant figures anyway that it will not affect your answer. So we know that 5,280 feet equals 1 mile, and therefore we could divide one by the other or the other by the first to get 2 different conversion factors. But we can also have some unusual things, like the statement, for every water we have 2 hydrogen atoms. Well, in that case, we know that there are 2 hydrogen atoms per 1 molecule of water, or 1 molecule of water per 2 hydrogen atoms, because they have a certain equivalency about them. One molecule of water has 2 hydrogen atoms. And I'm telling you this if you didn't already know it, but remember the formula for water is H2O. That means there are 2 H's, hydrogen, and 1 O. We don't usually write the 1. So here are the first 2 that I just mentioned, and here are the second 2 that I just mentioned. Now looking at C, this is a rate. 200 cars are produced each hour. In other words, the manufacturer is making cars, and 1 hour of work in this factory is equivalent to 200 cars being produced. So we could write this as 200 cars produced over 1 hour, or 1 hour over 200 cars produced. So it's a rate. We know that time and cars are not the same concept, they're not the same quantity, but there's an equivalency there because of this rate that we know. And if we look at this last one, water's heat capacity, and we'll talk about what heat capacity is later, is 4,184 joules of energy per 1,000 grams per 1 degree Celsius. Well, there are 2 pers here, so we divide twice. And when we divide twice, we really are just dividing by 1,000 grams, so 1,000 grams will be in the denominator on the bottom. But so will the degrees Celsius, because we're taking that number and dividing it also by a single degree Celsius. So in this case, we would create a conversion factor that initially looks like 4,184 joules divided by 1,000 grams, but also divided by 1 degree centigrade. Likewise, I can flip that and say that for 1,000 grams and 1 degree Celsius change, and we haven't learned what that means, but it's a change in temperature of 1 degree, we require 4,184 joules of energy. And this ratio, the first ratio that's shown here, is referred to as the specific heat of water. It tells you how hard it is to warm up water, how much heat you have to add to something in order to make the temperature go up. And I know in everyday English we use temperature and heat meaning the same, but in science they don't quite mean the same. So joules is a unit of energy, or heat in this case. Heat is a type of energy. And joules per degree gram would be the unit of specific heat in this case, which we'll talk about later. I noticed that there's a question mark next to the G in the final version. Unfortunately, that was a font conversion. It should say J over G degree, so it's joules over gram degree. So let's actually look at some examples here. The general equation is you start with the number of the old unit, and you want to get to the new number of the new unit on the right side. Well, when you create your conversion factor, if you start with your original unit by itself, well, in a fraction, that's the same as divided by 1. So the n number of old unit on the left really is n number of old unit divided by 1. So that's really the numerator. It's the top. If it's only by itself, you consider it the top. And if you want to convert it, you have to make sure that the old unit that you're destroying is on the opposite side. So in this case, in the conversion factor, which is always shown in parentheses here, the old unit is on the bottom because the old unit will cancel the old unit that's shown on the left with the n number of old units. So you have n number of old units. The old unit will cancel with the old unit, but the n number and the y number will still be there. They will not be canceled. Just the units will be canceled. And the only unit you will have left is the new unit. So this is the type of format you want to make whenever you're doing a conversion from one unit to another. If you start with your old unit over here, you want to build a conversion factor, and you want to put your units in first. So let's say we had an example where we wanted to convert, let's say, kilometers, and we had 5.6 kilometers, and I'm not going to go through the whole problem here, but we wanted to convert kilometers on the bottom to miles on the top. And I've told you that, 1 mile is equal to 1.609 kilometers, approximately. Well, we can then see that the kilometers will cancel the kilometers, and the only unit we'll have left is the one that we wanted all along, miles. And MI is the appropriate abbreviation for miles, by the way. So you then would take 5.6, multiply it by the 1, and divide it by the 1.609. And of course, you don't have to actually multiply by the 1. We already know you'll get the same answer. But that is what happens. You multiply all the top numbers, which are these top numbers, and you divide by each of the bottom numbers. We only have one bottom number here, so you're only dividing by 1.69. But keep in mind, if you had, say, 5.6 and 1, and we were dividing it by 1.609, which is the same thing as what we're doing. I'm leaving out the units for a second here. And what if you also had to divide by 7, for instance? Well, when you're typing this in a calculator, you will multiply the 5.6 times the 1, if you had to multiply it by 1. You will then divide by the 1.609, and then you will also divide by the 7, because both of these numbers are being divided. Do not write times here, or you will get the wrong answer. Your calculator doesn't see this line. It has no idea that the 7 is below the line unless you tell it, divide that one too. So make sure you use your calculator properly when you're doing this. So, going on with the format here. So here's an example, 4 feet, and we want to convert it to inches. Well, we know that 12 inches equals 1 foot. We first build our conversion factor. And how do you build it? You start with a parentheses and a line. That's the first thing you should write. You know you have feet in the beginning and inches in the end, so feet should be opposite of the old feet, which is on the top here, so your feet should be on the bottom, so to speak. And inches are the unit you want to create, so you put that on the top. I highly, highly recommend when you build a conversion factor, do it in this order. Number 1, make your parentheses with a line. Number 2, put in the units. And only after you put the units in, put in your numbers. Do not put your numbers in first. It's a very easy way to make a lot of mistakes. So, here's an example. A student has entered a 10.0K run, a 10-kilometer run, 10.0 kilometer run. How long is this in miles? 1 mile equals 1.609 kilometers. Okay, well, we're going to take the thing we have. What is the thing we have? The thing we have is the 10 kilometers. Always start with that and start converting one step at a time. Do we have a way to go right from kilometers to miles? Well, yes, we do, because we have a conversion factor that directly converts kilometers and miles, or miles to kilometers, either way. And now we build our conversion factor. We start with our parenthesis and our line. We know we're starting with kilometers, so they're on the bottom. If this was on the top, we put 1 on the bottom. And we want miles in the end, so that's going to be on the top. And then we look at our conversion factor and say, oh, what's 1 mile? Okay, it's 1.609 kilometers. So it's an easy way to build your conversion factor without really risking making a mistake. Does this answer make sense? Well, look at it. We started with 10.0 kilometers, and we ended with 6.22 miles. Now, you'll notice I've already rounded this answer to 3 significant digits. We actually have more digits here, but I rounded it to 3 because we started with 3, and our conversion factor had 4. So our final answer should be the lesser of those 2 sig figs, which is 3, and therefore our answer is rounded to 6.22 miles. Now, ask yourself, does it make sense? We know from the beginning that a mile is bigger than a kilometer. It's about 1.6 kilometers. It's a little more than a kilometer. So if we know that a kilometer is smaller, the kilometer unit is smaller than the mile, well, this many kilometers should equal less number of miles. And it's only a little bit less. We're going from 10 to roughly 6. Does that make sense? Well, yes, it does. So that's your check at the end to make sure that you've done your math right. And do we have the unit that we asked for? Yes, we do, miles. So everything worked out. It makes sense, and it has the correct unit, and it has the correct sig figs. So here are more examples for you. I'm not going to go through each example. You're given a conversion factor. It says how many gallons are in 8.7 liter jug. Well, we know we're given liters, so that's what you're going to start with. We know we're asked for gallons, and we have a conversion factor that in one step can convert gallons to liters. In fact, we know that a gallon is a little less than 4 liters. You might have heard that before. 4 liters is a little bit more than a gallon. So I'm going to pause. At this point, you can stop the video and see if you can work out the problem yourself. And then I'm going to show you the answer here. So we start with the number we have, 8.7 liters. We multiply it by a conversion factor that we created with liters on the bottom, gallons on the top, and we get our answer that the calculator tells us, and then we round it to the 2 sig figs that we started with. We start with 2 sig figs. Our conversion factor has 4, so 2 is the less of those 2. Our answer should have 2 sig figs. And it makes sense. The making sense part says, well, look at the gallon. The gallon is about 4 liters. Well, then 8 liters should be about 2 gallons, right? So, in fact, it's 2.3. Here's another one, but now we have something where we're asked how many miles per hour. We always write mph, but I highly recommend you convert that to miles, mi, over hour, hr. How many miles per hour are in 343 meters per second? So we're converting both the top unit and the bottom unit. So in this case, you have to do 2 conversions, one to convert the bottom unit and one to convert the top unit. So if we start with the thing we have, which is this value, and I'll circle right here, we start with that number. We have to convert meters to miles, but we also have to convert seconds to hours. And there are two conversion factors here. Now, I'll pause for a second. You can stop the video and see if you can do this on your own. Okay, and now I'm going to show you how this is done. And in fact, there are two conversion factors, one that will convert your meters to miles, and one that will convert your seconds to meters. Now, you'll notice, since seconds were on the bottom here, our conversion factor has to have seconds on the top to match it, and hours on the bottom. So if we have this, the seconds will cancel the seconds, the meters will cancel the meters, and all we'll be left with is miles on the top and hours on the bottom, and you can see that's what we get. And in fact, when you type 343 times 1 times 3600, and then divide that by 1, which you really don't have to do on a calculator, divide it by 1609, and divide it by 1, which again you don't have to do by the calculator, you will get this number here and more digits than that. I only showed you some of the ones that the calculator will show you. And then it also has a unit. These are the units that are remaining. Make sure you have the correct units. You can always cancel your units. If your units cancel properly and you get the unit you want, well then there's a really good chance you did it the right way. Now look, we start with a number that has 3 sig figs, 343. The 1 really has infinite sig figs. So it's 343 meters about per exactly 1 second. And we have a number that has 4 sig figs, and then this number is exactly true, so that's infinite. So this is infinite sig figs, this is 4 sig figs, and our original number is 3 sig figs. Well, obviously 3 is less than 4 or infinity, so our answer must have 3 sig figs, and we round this number to 767 miles per hour. So we ask ourselves, does it make sense? Well, yes, it does, at least in terms of the unit. The unit certainly makes sense. Do the sig figs make sense? Yes, it should be 3, and this is 3 sig figs. And now ask yourself, does the number make sense? Well, this is a little harder to do with a complex computation like this. You might not be able to do this right away, but you can say, okay, 343 meters per second, and I'm changing a couple things, and one has a conversion factor that's about 4,000, and one has a conversion factor that's about 2,000 on the denominator, on the bottom. Well, 4,000 divided by 2,000 is about 2, so this whole number is around 2. So if we multiply this number by 2, we should get somewhere in the ballpark of 700, and sure enough, we do. So it does, in fact, make sense. Now, I don't expect all of you to have the math skills to do this sort of thing, but it is a skill that you can get when you estimate numbers that are in the calculation. This is around 4,000. This one's around 2,000. That's an easy conversion to make in your head, at least to simplify it, and then you can ask yourself, does this answer make sense? Also, make sure you type all these numbers in at least twice in your calculator. Here's another problem that's very similar, and I'm not going to go through the whole thing, but you'll notice the question says the density of water is 1.00 grams per centimeter cubed. Centimeter cubed, a cubic centimeter, or cc, you probably heard that if you've ever listened to a medical TV show, or if you're in the medical field itself. A cc is a cubic centimeter, or centimeter raised to the 3rd power, centimeter cubed. This is the exact same value as a milliliter. It is a thousandth of a liter. So these two things are the same. So grams per cc, grams per centimeter cubed, grams per mil, they mean exactly the same thing. But you're asked to convert this into pounds per cubic foot. Well, pounds is a unit of weight, grams is a unit of mass, but we have conversion factors for that because we know how mass relates to weight on Earth. We know about the gravity of Earth. So we have conversion factors for this. And in fact, here are your conversion factors. You're given the conversion factors. These can also be found in your conversion sheet if you ever look for them. And in your conversion sheet, you might have a conversion, and I just want to point this out on the side here. You might have something that says 1 hour equals 60 minutes, which equals 3,600 seconds. And I'm just giving you an example. And maybe that equals 7.549 X units. And then I'm just making up a unit. We'll call it XMs. It's just a completely made up unit. And what that means is I can take any two of these, or I can take these two, or any pair and divide one by the other. They don't have to be right next to each other. I know that 60 minutes equals 7.59 of these made-up units I have, and therefore that's a conversion factor. Or I know that 1 hour equals this, and I can put this over this, or I can put this over this, or any one of these, any pair of these can be made into their own conversion factor. So they don't have to be sitting right next to each other when you look at the conversion factor table. So we have these two conversion factors, and we need to convert grams to pounds, and we need to convert centimeters cubed to cubic feet, or feet cubed. And we have conversions for each of these. So I'm going to leave these to you to do the calculation. I'll pause it here, and you pause the video. And now I'm going to continue on and show you the answer. So you can work this out. Here's another one. How many times does a heart beat a year? So you're asked for beats per year. And you're given beats per minute. So in this case, you're starting with 72 beats per minute. And you were asked to convert this to some number of beats per year. So we don't have to change the beats. We only have to change the minute. So we're going to need some conversion factor that has minute on the top and year on the bottom. Unfortunately, we don't have a single conversion factor. This doesn't exist. Well, you might be able to find it on your conversion sheet. But you can create this by doing a number of things. You can take beats, and I'm just going to abbreviate it as B, per minute, and convert that to beats per hour, because you know how many minutes are in an hour. And you can convert beats per hour into beats per day, because you know there are 24 hours in a day. And then you can convert days to years, because you know how many days are in a year. Well, maybe you don't know the exact number. It's for the purposes of this, you could say 365 in a non-leap year. In a leap year, it would be 366. So since a leap year is every 4 years, we actually say that the length of a year is approximately 365.25 days. I may have a more exact value for you in your conversion factor, but in any case, you can do this by using 1, 2, 3 conversion factors in a series, and that's how you would get from beats per minute to beats per year. And I'm not going to do this for you. I'm going to leave this to you to try. I'm going to stop here for a second. You can pause it if you want to try it. And now I'm going to show you the answer, and you can see here's a series, and at the end you may need to convert this because you started with 72 beats. Now I actually made a mistake here that I just realized. If the 72 is an approximate number, well, that's two significant figures, and in fact this is the exact correct answer, 38 million beats per year, if the 72 is approximate. But if somebody counted exactly 72 beats, well, that's an exact number, and this is an exact number, this is an exact number, this is an estimated number with 5 sig figs, and this would be exact. So this is infinite sig figs, infinite sig figs, infinite sig figs. This is 5. So our answer in that case would be rounded to 5 significant figures, and we would get an answer of 37,868,000, and we would leave it at that, beats per year. But that's if we had counted exactly 72 as opposed to estimating 72. So counting 72 means this has infinite sig figs. Estimating 72 means it has 2 sig figs. And you need to know which of those situations it is to do it properly. I have assumed in this calculation that it was approximately 72, and I'm sorry, that it was approximately 72 beats, but I neglected to 72 in that case. If it's approximately, I'm sorry, let me move that for a second. So if the 72 is approximate, this becomes 2 sig figs, and 2 would be the least, and that's the number we would use here. So I know it's a little confusing. So if this is 2 sig figs, in other words, it's estimated, our answer should be in 2 sig figs. But if our number was counted exactly, that's infinite sig figs, and our limiting factor here is the 5 sig figs, and this would be our answer. I know that was a little confusing. And the last one involves a couple different conversions. The price of gasoline is $2.15 per gallon. Your car averages 32 miles per gallon. How far can you travel with $7 worth of gas? So the thing you have here is the $7 worth of gas. This is a conversion factor. You can see the per, so that's divided by 1 gallon. And you can see the rate here, the speed, is 32 miles per. Remember, per just means divided by gallon. So we have two conversion factors, this one, and we have an original value, and we're going to use the two conversion factors to calculate distance. And I'm not going to go through this one. I want you to try this one on your own. This is a little harder than I would ever give you on an exam, but if you could do this, you're in great shape. So here are more examples for you. 50 feet convert to centimeters, 28.25 days convert to seconds. You're given the conversion factors in your table, or some of these you know already. And I'm not going to work through the problems. I'm going to pause here for a second so you can pause the video. And now I'm going to just show you the answers one at a time. So you can stop the video at any point between these. And that is the end of this section. So we're going to start on density next.